The first thing we'll look at today is how to find derivatives of sine and cosine. So remember last time we looked at the unit circle, and then we measured the length of the arc from this point and up to any old point like this. We called the length of that theta, and we thought of it as an angle, and then given some angle we had a point here which gave us an x-coordinate and a y-coordinate. In this case the x-coordinate is 0.8 and the y-coordinate is 0.6. Now if we vary the angle here, then we of course vary the coordinates, and if we draw as a function of the angle the x-coordinate, we get this function that you see here. And likewise, if we do the same thing for the y-coordinate, you see that starts at 0, right? Then we get this function here. So these two functions are the cosine function and the sine function. Now, to find the derivative of something, we needed to find first the difference in functional values and then divide by the difference in length and then take the limit between the 2 points to 0. So if we start by, basically we have to look at something like this for sine, right? So sine of x plus h minus sine of x divided by h. That would be the slope of the line between the points going through x plus h comma x sine of x plus h and x comma sine of x, right? So that would be 2 points on the x sine function graph. So for example this point and that point, then we would have a line going through that, and the slope of that would be this number. Now notice that sine is 0 at 0, right? Doesn't it get exactly? No, it's 0, right? So if we just use x equals 0, then this disappears, agree? So then our fraction here can just be written like this with theta instead of h. So what happens if we let this theta tend to 0? Then we should find the slope of this function at the point 0, right? 0, 0. So what happens? Here you can see the numbers for sine of theta. Here you see theta. Then what does this approach when this point or the angle tends to 0? It gets very close to 1, right? We can't divide by 0, so then it's nothing. But irrelevant of whether we're coming from a negative angle or a positive angle, this gets very close to 1 here. Agree? And in fact, if you mathematically take the limit, you will get a 1 here. Likewise, had it been cosine x plus h minus cosine of x over h, which would have been the slope of this function at the point, or something close to the slope of this function at the point x, right? Then we should first find out what is cosine of 0. Well, cosine of 0 is 1, right? So we could have replaced the sine here by a cosine and the sine here by cosine. Then cosine of x equals 0 would be 1, agree? So the corresponding fraction here would be cosine of theta minus 1 divided by theta. So that's the slope of a line going through this point, on the cosine function, this point and some other point close by if theta is close to 0, right? And what is the slope up here? Well, you can see it, right? But you can also see that right now it's, if we have a slope between this point and that point, we get a slightly negative number here. So clearly this function is going down a bit, or this line between this point and that point is going down a bit. Likewise, if we are just below 0, it's slightly positive. And what happens exactly at, or in the limit, because you can't divide by theta, right? What happens in the limit? Well, you get closer and closer to 0. But this tangent line up here is clearly 0, right? It has slope 0. If you wanted to draw a tangent, it would be exactly equal to this line that's already here. And clearly that has slope 0. So this means that we can now find the derivative of sine at 0, which is 1. This function has slope 1 here. And we can do the same for cosine at x equals 0. So that would give us this slope here, which is 0. Now, how do we get from that to any other point? Well, we just use the cosine and sine addition formulas. So remember last time we saw the cosine and sine addition formulas. So we could express sine of x plus h in terms of just sine of x, sine of h, cosine of x, and cosine of h. So this is what we do from this line to this line. We just expand this in terms of the trigonometric addition formula for sine. So sine of x plus h becomes sine of x times cosine of h plus sine of h times cosine of x. So these two terms is the same as this. Now we have sine of x here, we have sine of x here, we have cosine here. So let's try to see if we can collect these terms somehow. So all the terms with a sine of x, we take in one fraction. That gives us this. So why is that? This sine is that and that. If we multiply it onto -1, that gives us this minus here, right? And cosine h, which is this. Everything divided by h. So we have an h down below. Last time some people said that they had trouble calculating with fractions. I encourage you to practice that. You can use something like Khan Academy for this. Now what about the remaining term? It's this, right? How does that look? Well, we have a cosine x, the factor here. Then we have sine h over h, which is what we then have here. Now note that this term is exactly a term of this form, and this term is exactly a term of this form. And we know the limits of these two. So what do we get in the limit h tending to 0? We get that this tends to 0, so sine of x is multiplied something that goes to 0, and our cosine of x is multiplied by something that tends to 1. So there's an arrow here indicating that it's a limit we're checking. And then clearly I have written something incorrect here, right? If you multiply sine by 0 and cosine by 1, you're not left with a sine but a cosine, so this should have been a cosine. I apologize for that. I will correct this for h tending to 0. So what is the take-home message of this? Well, we looked at this differential quotient here, difference quotient here, and then we took the limit and which gave us this cosine, it should have been, of x. So in other words, if we differentiate the function x at the point sine of x at the point x, we get cosine of x. And we could have done something completely similarly for cosine. I will not drag you through that. So now we know how to differentiate sine of x and cosine of x. So sine of x is just cosine, and cosine of x differentiated is minus sine of x. You can always, if you're in doubt where to put the sign, just make this drawing, right? Draw the unit circle start drawing the cosine and the sine, and you can see that this clearly has a positive slope, so of course this comes with a plus. This starts going down, so it starts with a negative sign, so it has to be with a minus.